Hello and welcome to this video about nuclear fission and fusion. We're going to start off with fission first of all, which means we're talking about splitting up atomic nuclei. So the nucleus of an atom. Nuclei just being the plural for more than one nucleus. So we've got a radioactive material like uranium-235, and that is going to split up into two smaller elements. And to do that, first of all, what it does is it absorbs a slow-moving neutron. And when it absorbs that neutron, obviously its mass number is going to increase by 1, so it goes from uranium-235 to uranium-236. This becomes really unstable, and then it will split. Okay, you'll get that fission existing. And when that fission happens, you get two smaller elements. So for example here, 92 for krypton and 141 for barium. And you get loads of energy released as well, which is really important. And we'll talk about how we use that energy in just a second. Further to this, you also get 2 or 3 neutrons released. In this case, we've got 3, but in the reactions, you'll either get 2 or 3 neutrons released. And as you can see, if the mass up here was 236, that needs to be conserved. So if you add up the mass of krypton, 92, with barium, that would give you a total of 233. But not forgetting these neutrons down here, which have a relative mass of 1 each, that would make 234, 235, 236 up here. Now you won't need to remember the specific elements that are made in this nuclear fission, but you will need to work them out from the information given in a question. So these neutrons here that are released, they can go on and of course collide with more uranium-235, and because 2 or 3 are released, we get this chain reaction occurring where they keep releasing neutrons and they go on to collide with more uranium-235. Now you might need to complete a diagram like this to show how the chain reaction happens. So all you need to do is show that this neutron will go to collide with another uranium-235, and that will split into your krypton and your barium, and you will have 2 or 3 in this case, neutrons released. And you would show that for each of the neutrons that come out. Okay, so for example, this one here, you would also go on to show that that would go into uranium-235 atom, which would then split into your krypton, your barium, and then 2 or 3 neutrons released. And over here, this neutron would obviously go to another uranium-235, and so on and so on. That is why a chain reaction occurs, because you end up with from one slow-moving neutron being absorbed, 2 or 3 more being released in nuclear fission, which can go on and cause more unstable nuclei and more splitting of these nuclei. So the important thing then for this nuclear fission is that energy is released. And we use nuclear fission in nuclear reactors to get energy, to heat water, to turn a turbine, which turns a generator and creates electricity. And you would have seen perhaps images of such nuclear reactors before. And in a nuclear reactor, you will have your nuclear fuel in the reactor. And that could be uranium-235, as we mentioned before, or it could be another radioactive substance called plutonium-239. Now, unfortunately, you will have to remember these radioactive substances here, uranium-235 and plutonium-239. Now, inside this reactor, this is where nuclear fission will happen. So these nuclei will be absorbing the neutrons and splitting and releasing more neutrons and, most importantly, energy, which will then heat the water. Another important thing about this, though, is the control rods in there. What these do is they control the rate of nuclear fission. And these are really important. What they do is they absorb neutrons. So if you remember before when we drew the chain reaction with all those neutrons being released, they obviously would go on and collide with lots more uranium-235 or plutonium-239 and cause them to split and cause more energy released. What these do is absorb those neutrons so that can control the rate of reaction. If you don't want those neutrons to go on and collide with more nuclei, you can absorb them and take them out of the equation. So moving on to nuclear fusion then, unlike fission, which was the splitting of atomic nuclei, fusion is the opposite. It is the joining of two atomic nuclei. So it's two nuclei coming together and releasing energy. And this fusion is the reaction that happens in stars. For example, our sun, and it releases loads of energy. More energy, in fact, than nuclear fission does. Okay, so it's really important. And what we're trying to do actually is, like we produce energy by nuclear fission in reactors, we are trying to build nuclear fusion reactors as well, but we're not having very good success with building these nuclear fusion reactors. And the reason being is, like the stars, this fusion happens in really high temperatures and really high pressures, and we're struggling to build equipment that can hold such high temperatures and pressures to release energy. And one of the important things is that we're spending too much energy and too much electricity to heat the equipment up to these high temperatures, and we're not getting the energy back that is released. But maybe for the future, this kind of nuclear fusion will be something we can use to generate electricity. So what is it? A quick example then is basically two small nuclei coming together. So for example, you could have two different isotopes of hydrogen. We can tell they're two different isotopes because they've got two different mass numbers coming together to form helium. So the fusion here, two lighter elements come together to form a heavier element. And of course, in the process, we get energy released. Okay, so in summary, nuclear fission was the splitting of atoms to release energy, happens in nuclear reactors with elements such as uranium and plutonium, whereas nuclear fusion happens in the stars. It's the joining of atomic nuclei with two smaller nuclei coming together to form a heavier nucleus. So I hope you found that useful. If you did, please press the like button below and feel free to subscribe.